Hello everyone, my name is K. Reddy, working as assistant professor in Tegal Krishna Engineering College. In my previous video, I explained phase shifted PWM techniques. In this video, I will explain level shifted PWM techniques. In this level shifted PWM techniques, I will control cascaded HPG multi-level inverter. This is phase shifted PWM technique output waveform. Okay, here 4 carrier waves is there 1, 2, 3, 4. Okay, I will provide a link in description. Kindly watch this level shifted PWM technique. Now I will explain phase shifted PWM techniques. Already designed circuit in MATLAB. I will explain this circuit diagram. Okay, I took 4 repeating sequence waves here and one sine wave. Okay, in sine wave, I gave here amplitude is 0.85 and frequency 2 pi into 50. This is frequency, this is amplitude. Next, I will go to repeating sequence 1. Here I gave frequency 500 edges. Okay, this frequency is 500 edges. Here time values are first initial value 0 and 1/4 means 25% time value. Next here 1/2 means 50% time value. Frequency time t is called 1/f. That's why I gave by here f 500. Next output values it vary from 0.5 and 1 again 0.5. Okay, 0 example 0.5 to 1, 1 to 0.5 like wave repeating. Next, I will explain repeating sequence 2. Time values I did not change 0, 1/4 and 1/2 frequency. Here output values I change 0, 0, 0.5 and 0. Okay, 0 to 0.5 again wave come from 0. This is second repeating sequence. I will explain third repeating sequence. In third repeating sequence, output values it varies from minus 0.5 and 0 and minus 0.5. Time values 0, 1/4 and 1/2, 500 by 500. Next, this is fourth repeating sequence. It varies from minus 1, minus 0.5 and minus 1. This fourth I will explain in waveform graph. I will take one mux. I will take one mux and one scope. I will connect all these 4 repeating sequence values and sine wave connected to this dmux. First I will connect it to sine wave. Next I will connect to this repeating sequence 1. Next I will connect to this repeating sequence 2. Next I will connect to this repeating sequence 3 and I will connect to this repeating sequence 4. Now I will connect to this output here. Now I will run the circuit. Now I will show output. Okay, this is the output waveform. This output waveform have 4 triangular waves. This is triangular wave 1. It varies from 0.5 to 1, 1 to again 0.5. This is second triangular. It varies from 0 to 0.5, again 0.5 to 0. This third one, it varies from minus 0.5 to 0 and 0 to again minus 0.5. This fourth triangular, it varies from minus 1 to 0, minus 0.5, again minus 0.5 to minus 1. These 4 are 4 triangulars. These 4 triangulars, again once I will show 0.5, 1, 0.5. Okay. This first one 0.5, 1, 0.5. Next, the second repeating sequence, my 0, 0.5 and 0. This is 0, 0.5 and 0. Next, this third repeating sequence, minus 0.5, 0 and minus 0.5. This third minus 0.5 and 0, again 0. Okay, like this output I got. Okay, this is one sine wave. Let's play one wave. Okay, it start from here to here. This total is one full cycle, 4 carrier waves. Next, I will go to this 4 one here 4 relation operators greater than or equal, less than equal, greater than or equal, less than equal, like unipolar pulse width modulation. First, the sine wave connected to this relation operator input. This one also. These are four relation operator first terminal connected to sine wave. These four triangular waves connected to each one triangular wave connected to relation operator second terminal like this. Okay. Next, relation operator output connected to four switches S1 and this S2 is complementary switch. This S1 and S2 are operated in complementary. That's why I give S1 complementary switch S2. Next to this greater than or equal. Next less than or equal. When S1 on, S3 here switch off. Okay, like that. When less than or equal, S3 and S4 are complementary manner. Okay, next greater than or equal S5 and S6. It is lower HB, S5 and S6 are operated in complementary manner. Next, S7 and S8, these two are operated in complementary manner. These are from and go blocks. I explained how to use from and go blocks in MATLAB Simulink. In my previous video, I explained how to use from block and go blocks. Okay, this is the main circuit diagram. Sine wave and repeating sequence wave, relation operators and logic operators. Okay, not get. I generated total 8 pulses. Okay, the 8 pulses I gave here. S1 and S2, S3 and S4. Next S5 and S6, S7 and S8. Now I will run the circuit. I will show output voltage waveform. Okay, I got here 5 levels. Level 1, 200 volts. Level 2, 100 volts. Level 3, 0 volts. Next, level 4, minus 100 volts. Level 5, minus 200 volts. Okay, this is the output voltage waveform. Now, I will check THD voltage waveform of this inverter. I will go to scope. I will double click this one. I will go to history. In history, I will remove this limit data point. Next, I will save here. Name VI. I will change the structure with the time. I will apply this one. Okay. Next, I will run this circuit. I will go to discrete. I will go to FFT analysis. In FFT analysis. Okay. This I will apply here 50 Hz frequency. I will take 3 number of cycles. Start with time. I will start waveforms with 0.02 seconds. Next, I will apply display. I will click. Okay. I got 36.68% THD. Okay. This is now I will save this waveform, output voltage waveform. I will double click here. I will change this diagram color and I will save with high resolution. I will double click this one. Next, I will go to file. In file, print figure. I will click print figure. In print figure, here have edit option is there. In edit option, I will double click print figure. Here property editor option is there. Click here property edit option. Next, in property edit, here figure color option. Change here from white color. Next, in diagram also, I will change color white. Will change this color. Next, I will change output waveform color also. I will change here width of the waveform. Next, I will change here axis color and I will change font size in axis. I will apply 40. I will keep bold. Next, I will write here y-axis name. Output voltage. I will type output voltage. In x-axis, I will type here time in seconds. Okay. This is the inverter output voltage waveform. Now I will save this in JPG format. I will click here save as option. In save as I will select here JPG. I will choose desktop. I will type name here phase shift level shift PWM LEVEL level shift PWM. Now I will save this waveform. Now I will show. Okay. So this is finally output waveform 5-level inverter using level shifted PWM technique. Okay, thank you for watching this video.